Here's an example with some ropes holding up a crate of some kind. They're telling us about the angles and the weight of the crate. And in the end, they give us these two angles for the ropes, and they want us to find the force or the tension. Same thing. The tension in a rope is the force the rope exerts. So, all right. So one of these ropes, here's a central point. One of these ropes is pulling up to the right, like so. Let me do that again. Up to the right, like so. And the other rope is pulling up to the left, like so. And then we have the crate pulling straight down, right? That one's pretty simple. The vector for the crate is really very simple. It's 0, negative 610, right? It's pulling straight down 610, not sideways at all. So we've got to get the other vectors, though. So for the other vectors, let's focus on the origin right here. This 55-degree angle right here is the same angle right there. This and this are both the rope with the horizontal. So I just made this line perfectly horizontal, just like this one is. So the angle the rope makes with the horizontal is going to be the same either place. So that's 55 degrees. Same thing. Okay. So then what does that mean? That means force 2 vector, remember how we do it, is going to be whatever force 2 is. We don't know what force yet is. I'll just say force 2 is going to be F2, whatever that tension is in rope 2, I don't know, cosine of 55 degrees, comma, whatever that tension is, force 2, sine of 55 degrees. Okay, now the harder one is going to be the force 1. So force 1, right over here, here's force 1. Now we have to get this angle. That's the trick. You must get angle. Theta must be from 0 degrees counterclockwise, right? So you think, well, this is 28. Well, that means this is 28. Right there, that's 28. So how can we get the angle? Theta must be 180 minus 28. Theta must be what? 152 degrees? That's the angle of force 1, 152 degrees. That's the trick that'll trick a lot of people. Because you say, well, this is 28 because it's horizontal and this is horizontal. That's true. So this is 28. But we need the angle from 0, from here, counterclockwise. That's the angle for the vector. It's always from 0. It must be from 0 counterclockwise, and this is 0 degrees. We defined on the axis system 0 straight to the right, so we got to go from 0 to the vector. So that's 180. That's all the way to 180, back up 28, right? Which is 152. So it's 152 degrees is the angle. So then that vector is whatever force 1 is. We don't know. We're trying to find that. Cosine of 152 degrees, comma, force 1, sine of 152 degrees. Is that making sense? So we have force 2 vector, force 1 vector, right? Where I'm getting those because to find a vector, you always just take the magnitude cos theta for the x and magnitude sine theta for the y. That's the x and the y. So we did that, and then here's the x and the y. For the crate, it's just all y straight down, negative 610. Now, how do we, what do we do now? Well, the crate's not moving. It's standing still. So what that means is all the forces in balance. When the crate is not moving, so the sum of the x forces equals 0 and the y forces equals 0. They must, right? If they, if you push on something, it's going to move. If it doesn't move, there's got to be force pushing back. Even if that force is friction, there must be a force pushing back that's equal to it, or it would move. So when things are not moving, all the forces add up to zero. They're in balance, we call that. So, okay, so that means I can take all the x's. Let me come down here and do exactly this. I'm going to go the sum of the x forces. So what is the sum of the x forces? Well, I've got this x force. Doesn't matter what order we do them in. F2 cosine 55 plus this one, F1 cosine 152 plus 0, this one here, must equal 0, right? All the x forces must add up to 0. Do you see that? Let me show you that on the picture. Do you see how the this force right here? Look at this force right here. This force, this rope, he is pulling. Can you see how he's pulling? He's pulling left and up, and the rope on the right is pulling right and up, and this thing is pulling straight down. So these two right and left pulls must actually be equal because the crate isn't pulling anywhere. So that's what we're basically saying. The right and left pulls have to, one of them's negative. This is a negative number pull, and this is a positive. So they have to add up to equal 0. The negative and the positive pulls add up to be 0, don't they? And then this is a positive upward pull. This is a positive upward pull. And this is a negative down pull. This negative and these two positives add up to be 0 for no net, for the vertical force net total 0, sum total 0. So, all right, so I got that equation. And then the sum of the y forces must be 0. So I take the y forces. That would be the y force here and the y force there. F2 sine 55. Whoops, come on. Plus F1 sine 152. Plus, and then the y force here, the negative 610. Plus negative 610, it's negative, it's downward, must be 0. Again, sum of the x forces must equal 0, and the sum of the y forces must be 0. Why? Because it's in balance, right? The upward forces must equal the downward force. It's negative numbers, so these two positive numbers plus that negative number must make 0. There's no net vertical force on the crate, or it would be moving. And the two sideways forces must add up to be 0, one negative, one positive, or the thing would be moving sideways. Okay, so what now? So we've got two equations with two letters. So this is a hard problem. I'm going to take this equation, bring it down here. I'm going to use my calculator. F2, I'm going to find the cosine of 55. Make sure you're in degree mode. So this is going to be 0.573576. You better use about 6 digits, just to be safe. Plus, and then cosine of 152 is a negative 0.882948 F2 equals 0. I got rid of that 0, and I put the F2 in the back and the F1 in the back. I hope I didn't confuse you. It's the same thing either way. Whoop, this should be F1 over here. I messed up, didn't I? Whoop, come on. This should be F1. All right, and this is F2. Doesn't matter front or back, whatever. Okay, so I can solve that equation for F1 or F2. It doesn't really matter which one. Let me just solve for F2. So I'm going to add the 0.882948 F1, 0.882948 F1 to both sides. Cancels out here, and we get 0.573576 F2 equals positive, right? These canceled. Positive 0.882948 F1, and then divide by the 0.573576, both sides, 0.573576, boom, boom, and I've got F2 equals, I'm going to divide that on my calculator. Divided by, I'm getting 1.539373. Use, again, 6 digits. F1, right? The F1 is still here. I just divided the two numbers. I just divided the 0.88 blah, blah, blah number over the 0.57. So I've got F2 in terms of F1. Now I can plug that into the blue equation, right? I'm plugging one equation into the other. So I started with the X forces equation, brought it down here, and solved for F2. You could have solved for F1. It doesn't matter. Let me bring down now F2 sine. It's bringing down this blue one. Now I'm going to use the blue one. Remember how to solve two equations with two letters? You solve for one equation. I'm going to move this. I'm going to add the 610 to both sides here. Get rid of it there. Equals positive 610, right? And then I'm going to take this F2 here, and I'm going to plug it in for F2 right there. Do you see that? Remember this? Solve for one equation, plug into the other. So this is going to become 1.539373. Wrong problem here. Sine 55 degrees. No. Come on, Brett. I skipped the F1 there. F1, right? It includes the F1. And then sine 55 degrees plus F1 sine 152 is 610. So let's take this number and multiply by sine 55. On my calculator, I'm getting 1.260981. Whoops, no more sine. I just multiplied this times this. The F1 is still there. And then sine 152, I'm getting 0.469472. F1 is 610. Now, I'm almost there. I can add these like terms. Just add those two numbers up, right? It's like 3x and 4x makes 7x, right? We have, 1.26 F1 and 0.469 F1. Add them up. I'm getting 1.730453. F1 is 610. We've almost got F1. Divide by 1.730453. 1.730453. Boom, boom. F1 equals, I use the answer button a lot on my calculator. It helps speed things up. 352.508941. We got F1. We've got force 1. The tension in rope 1. We've got it. Now that we have force 1, we can go back and get force 2. Where? Right here. See how force 2 is already alone right there? So bring that one down. This one right here. Bring that down right over here. Force 2 is 1.539373 force 1, right? So then, almost got this one. Take this force 1 we just found, plug in right there for force 1, and we will have our hands on force 2. So force 2 must be 1.539373 times force 1, which is 352.508941. Which is still on my screen, so multiply by 1.539373 equals, so I'm getting force 2, 542.642746. There we go. There's force 2, the tension in rope 2. Here's the tension in rope 1. We found the tension in both of those ropes. by a lot of hard work. This is what engineers do. If you're interested in engineering or architecture, things like that, you do this all the time, this kind of calculations. So what did we basically do? We turned both those ropes into vectors right here using, magnitude cos theta for x and magnitude cos theta, sine theta for y. So it got vector force 2, vector force 1, and here was the vector for the crate, just straight down. We realized the crate's not moving, so the sum of the x forces must be 0 and the sum of the y forces must be 0. So we added up the x forces to equal 0 and the y forces. We realized we had two equations with two letters. What two letters? F1 and F2. F1 and F2 were our letters in both equations. So I took the top equation and got F1 alone, just kept working. Got F2 alone. Got F2 alone right there. Wait, is that what I did? I'm getting lost in what I even did. What did I do? I took the top equation and I solved for F2. Yeah, I solved for F2 right there. And then I plugged it into the other equation. I took one equation, got F2 alone, plugged it in for F2 in the other equation. Okay, and then I just had F1. That way I only had one letter. You solve one equation for one letter and plug it into the other equation, then you get the other equation to only have one letter, F1. You can solve for F1. I got F1 right here. Then I plugged that back into the F2 equation, and I got F2. There we go. Not an easy problem. That's why engineers are in demand.